Okay, so we will be discussing uh, the part 2 of our module 3. Okay. So objectives for this presentation, students would be able to define radiation, identify the types of radiation, list and discuss the electromagnetic spectrum, explain the wave particle duality. Okay. So radiation is everywhere. Okay, as you can see in the illustration, so well, we live in a sea of radiation. May radiation sa rocks, sa lupa. So we call them terrestrial radiation. Okay? Mayroong radiation sa hangin. So nandyan yung radioactive element na radon. Sa katawan natin, nandyan yung radioactive element na potassium. Gayon din sa saging, di ba? May potassium. Then, of course, from the sun, we have the cosmic rays and the ultraviolet rays. So they are all forms of radiation. Okay? But how do we define radiation? Okay. So paano ba natin siya dapat i-define? Do you have any idea or do you have your own definition of radiation? Okay. So radiation, there are several ways to define radiation. First, we define radiation as a form of energy. So this energy is transmitted through space without any conducting medium. Okay? That means it can travel even in a vacuum. Okay? And then another definition is that it is a process of emitting energy. Okay. So it is a general term used to describe the process of emitting radiant energy in the form of either waves or particles. So we have two definition na. So syempre, yung kasunod, define pa rin as energy in transit. Okay? And then, the last na definition dito sa atin slide is, it is a process of transmitting waves or particles to space or some medium or such waves or particles themselves. Okay. So it is still defined as a process. Okay. So that is radiation. Another thing, radiation is also one form of transferring heat. Okay. So uh, it isa siyang paraan ng paglilipat ng heat. Okay? So tatlo yung ating definition na it's a process of transmitting or emitting radiant energy in forms of waves and particles. Then it is a form of energy transmitted through a space without any conducting medium. Okay? And it is the process of um, transferring heat, okay, from one uh, surface to another. Okay? So, yan. Anong ibig sabihin ng medium? So, it is a substance or an object that carries the wave or transfer energy. Okay? So, yan. The plural for medium is media. Okay? So, ayan na. You should formulate your own definition of radiation na madaling tandaan. Basta nandun yung mga common elements. Okay. Like ano ba yung mga common elements? Or important elements? Kaysa sa uh, definition na number 1 natin, energy. So it is an energy that can travel through space, okay, even without any medium. So, ganun lang siya kadali mag cup up ng ating own definition. So, you should practice that para it can help you also in your study. Okay. So, this is an example of a wave. Oscillating wave yan. Okay? So, as you can see, merong valley, saka merong crest. Okay? So, uh, sa ating RadTech, we will discuss or we will be discussing radiation as a form of energy. Okay? So there are two types of radiation. So according to its effect on atomic particles. So one is ionizing radiation and the other one is non-ionizing radiation. So ano bang ibig sabihin nila? An ionizing radiation has a sufficient power or energy that can ionize atoms. And ionization is the process of removing an electron from an atom. Okay? So, dahil nandyan yung salitang ionize, ionization, so when we say ionizing radiation, it is a type of radiation that is capable of removing an electron from an orbital shell. Siyempre, saan pa ba mariremove ang electron kung hindi sa kanyang kinalalagyan, which is the orbital shell. However, contrary to ionizing radiation, non-ionizing radiation, okay, though it has also have energy, its energy is not sufficient enough to cause ionization. The only effect of ionizing radiation to atomic particles is that it can cause excitation. So yung bang tipong sinabihan ka uh, ng boyfriend mo or ng girlfriend mo, love, may regalo ako sa iyo mamaya. Pero alas 8 pa lang ng umaga, di ba? So feeling mo excited na excited ka. So something like that. So excitation. So it is an effect on the atomic particles such as electron na shake lang siya, magba-vibrate. But that particular subatomic particle will not be ejected from its atom. That's why that energy or type of radiation is called non-ionizing because that radiation cannot cause ionization. Okay, clear po ba yung ionizing and non-ionizing radiation? Malinaw po. Hindi kayo malilito? Promise, hindi kayo malilito? Okay, so, punta naman tayo doon sa other types of radiation. So, types of radiation according to form. So, I did mention it last meeting. Diba? So, we have two. Electromagnetic radiation, okay, that travels in the form of electromagnetic waves. Okay? It is also a type of radiation in which transportation is a combination of electric and magnetic field. Okay? It is it does not need any medium for it to transfer, okay, or to move from one position to another. And however, the speed, amount, and direction of energy flow are influenced or is influenced by the presence of matter. Okay, what do we mean by that? Kung may nakaharang na matter or object doon sa path na dadaanan ng electromagnetic radiation, depende doon sa klase ng radiation kung siya ba ay magpapass through. Depende sa klase, sa bilis. Siyempre yung bilis, pare-parehas naman sila ng bilis, di ba? So, depende sa amount and direction ng energy flow. Okay. So, regardless of their frequency and wavelength, electromagnetic waves travel at the same speed in a vacuum. Okay? And that is the speed of light, which is exactly 200,099 or 299,792.458 kilometers per second, or approximately 186,282 miles per second in a vacuum. Okay? So when we say vacuum, it is a space wherein there is no presence of any air and any air particles. Free from air, okay? Okay, so next is the particle radiation or particulate radiation. Okay, it is a form of radiation, okay, or energy in the form of moving subatomic particles. Okay, it either has mass or charge or both. Pwedeng walang mass, pwedeng walang charge. Okay? So what are the examples of this? Okay, we discussed these types of radiation, pero we know it or you know it as in the form of radioactive decay. So later we will be discussing the alpha, beta particles or radiation as a type of particulate radiation instead of a type of radioactive decay. Okay? Okay. So this is an illustration of a of an electromagnetic spectrum. Okay. As you can see, there are measurements. Okay. Measurements of wavelength in meters and measurement of energy. Ano kanyang unit? Electron volts. Okay? So, ayan. From lower to higher energy concentration and from longest to shortest wavelength. Okay? So, the electromagnetic spectrum is presented as a continuum. Okay, when we say continuum, so siya ay continuous yung kanyang uh, listahan ng radiation. Kasi once na magbago yung size ng uh, or yung length ng wavelength. So, it can become, okay, or it can have more energy. For example, in ultraviolet rays, diba? Nakalagay dyan, kung makikita nyo, siya ay hindi naman ganun, medyo malaki yung kanyang yung kanyang variation. Okay? So, kaya nga yung ultraviolet rays ay some considered na yung kanyang other half ay merong ionizing radiation properties. Okay, but for the sake of our discussion, UV rays are considered as non-ionizing radiation. Okay, malinaw po ha. Kahit na ang ultraviolet rays can cause cancer, still it is non-ionizing radiation. So, the electromagnetic spectrum is a continuum of electromagnetic energy. Ibig sabihin, dire-diretso siya. Okay? From lowest to highest energy. So the frequency is from 10 to the second power until 10 to the 24th power hertz. Okay. So, and then yung wavelength from 10 to the 7th power to 10 to the negative 16 meter. Okay? Okay, I have a question. What is the relationship between frequency and wavelength? Inversely proportional. Very good. So yan. At least natatandaan nyo. So the electromagnetic spectrum includes the entire range of electromagnetic energy. That is why it is called a continuum. Okay. There are three regions important to radiologic science. Okay. So, nandyan yung visible light region, the X-ray region, and the radio frequency region. So, yung tatlong region na yan, or types of uh, electromagnetic radiation, okay, are important to our field. Yung visible light, so siya ay nagagamit natin sa radiographic and fluoroscopic images. Okay? So, sa paanong paraan, di ba? X-rays are transformed into light kapag siya ay nagpapass through sa intensifying screen. Tama ba? Nandun na ba kayo? Nandun na ba kayo sa film screen? Wala pa siguro. Okay. So, the intensifying screen is a layer or part of the cassette. Okay? So, pag nag-pass through doon ang X-ray, it converts uh, X-radiation to light energy. At yung light energy na yon, siya yung magpro-produce ng image sa film and yung iba magpapass through at ba-bounce back doon sa other side ng intensifying screen. Okay. So sa fluoroscopic images, ganun din. Yung tinatawag nating part ng fluoroscopy na image intensifier, so it also converts X radiation to uh, light, then light to electron, then electron to visible light. Hanggang sa siya ay makaform ng image, ng real-time image. Okay, the X-ray region, syempre, very important. It is the fundamental, okay, uh, aspect or pinakamahalaga sa ating field, okay, and needed to produce a good quality radiograph. Okay? Then, radio frequency region or RF, sa abbreviation RF. Okay? So it is used in MRI. Okay? Then others, which is not used in diagnostic imaging. UV light, ginagamit ng mga PT, as well as infrared and microwave radiation. Okay? So, diagnostic ultrasound is not part of the electromagnetic spectrum. Bakit kaya? Ano ba ang ni-utilize ng ultrasound? Di ba sound? And sound is also a form of radio frequency, tama ba? So bakit kaya hindi siya kasama sa electromagnetic spectrum? Very good. Hindi siya nakakapag-travel sa vacuum. Kasi sound needs a medium, saka yung isa pa, kailangan niya ng medium in order to uh, travel and transmit its energy. Okay? Eh sa loob ng vacuum, wala namang medium, di ba? Kaya sound cannot travel in a vacuum. Ayan. So, ultrasound, okay, it is the wave of moving molecules. Okay? It requires matter or medium and it cannot exist in a vacuum. Okay, so yan yung reason. Diba? In contrast with the electromagnetic energy. Okay? So yung electromagnetic energy, hindi siya wave na or yung electromagnetic wave ay hindi siya yung klase ng wave na moving molecules. It is an energy itself. Diba? Okay. So again, ano naman siya? The measurement or parameters of the electromagnetic spectrum. Nandiyan na naman, electromagnetic waves pa rin. So, we have energy, and the unit of energy is electron volts. Frequency and its unit is hertz. Then wavelength, the unit is lambda. Okay? Sorry, meter pala. Meter ang unit. Ang symbol ay lambda. Okay? So this is a graphic representation of the electromagnetic spectrum. Medyo malabo lang pero yan. So from radio waves to cosmic uh, cosmic rays. Okay? So dapat alam niyo yung pagkakasunod-sunod niya ng electromagnetic spectrum. Okay. So the energy of a photon is directly proportional to its frequency. So ayan, meron na naman tayong relationship. What is the relationship of energy of a photon to its frequency? It is directly proportional. Okay? Bakit? The more number or uh, the more number of waves, the greater the energy of a photon. Okay? Or the greater the frequency, the greater the energy of a photon. The lesser the frequency, the lesser the energy of a photon. Okay? So visible light, if you remember the first representation of the electromagnetic spectrum, makikita nyo doon uh, napakaikli lang nung visible light na na-occupy doon sa spectrum, di ba? So it occupies the smallest segment in the EMR spectrum. It is described in terms of wavelength, kasi nga ay wave. Okay? Range is 400 nanometer. So, kapag yung energy niya yung wavelength niya ay 400 nanometer, we can see it as we can see that particular light with the color of violet. And kapag nag-increase siya to 700 nanometer, so from violet, magiging siyang red. Okay. With uh, the changing or the changes that occurs in the wavelength, the size of the wavelength, okay, it can also change the color. Okay. Then refraction is defined as a deviation, of course, that occurs when uh, photons of visible light travel in straight lines, then pass from one transparent medium to another. Okay? So mamaya tingnan natin kung may image, kung may photo tayo regarding refraction. Okay? Then sunlight. So sa sunlight, meron tayong two electromagnetic radiation. Okay, we have the infrared and UV light. Two invisible light yon. And bukod pa doon yung visible light. So bali tatlong electromagnetic radiation ang present sa sunlight. Then infrared. Okay? So nakaabot ba kayo doon sa mga lumang cellphone na may infrared? However, hanggang ngayon naman, yung ating mga excuse, yung ating mga cellular phones or mobile phones or smartphones ay meron pa ring infrared. So sabi dito, longer wavelength than visible light but shorter wavelength than microwaves. So ano lang ang kayang gawin ng infrared? So it produces heat in any substance on which it shines or radiant heat. So katulad ng binanggit ko sa inyo before, lahat naman ng nasa ng non-ionizing radiation, ang kanilang principal and general effect is thermal elevation. When we say thermal elevation, production of heat, di ba? Okay? So UV light, it can cause sunburn, lies between visible light and ionizing radiation. So, yan. Radio frequency, low, low energy, long wavelength. Ang range niya ay 0 to 0.3 kilohertz to 300 gigahertz. Okay? Yung range ng MRI ay 1 to 100 milliamperes. hertz. Okay? So ito yung another representation ng ating electromagnetic spectrum na nakalagay or naka-indicate yung uh, respective energy, frequency, and wavelength. Okay, so radio frequency, so pasok dun yung MR imaging, di ba? Katulad nung binanggit earlier. So from 1 kilometer, so hindi lang 1 kilometer, so kilo, mega. Okay, so 10 raised to the 6 power, 1 meter hanggang 1 meter, yung radio frequency. Then microwaves from 1 meter to 10 raised to the negative 4 meter. Okay? When we say visual imaging, so nandyan yung ating uh, fluoroscopy and uh, yung ginagamitan ng intensifying image intensifier. Okay? So X-ray imaging or X-rays. So between 10 to 11 and 10 to the negative, sorry, 10 to the negative 11 and 10 to the negative 10 meter. Okay? So, ayan yung mga different types ng X-rays. Mega voltage X-ray, uh, super voltage diagnostic range. So these are ranges ng X-rays, contact therapy, and Grens rays. Okay? So, syempre, as you can see, you can derive that the shorter the wavelength, the greater the energy. Okay? So, paano natin nalaman yon? Okay? Ito yung wavelength. So, negative, kasi paikli siya ng paikli. Positive, pahaba ng pahaba yung wavelength. Okay. While in the energy, baliktad. Yung positive is going up and negative niya is going down. Meaning the shorter the wavelength, the greater the energy. The longer the wavelength, the lesser the energy. Okay? So yan. So, yan. Ito yung example ng refraction na sinasabi ko kanina. So a prism is let's say it is a crystal na pag merong visible light na pumasok doon, so it can uh, produce light with several colors. Okay? And yun nga, ito nga yung naging uh, kinalabasan, example ng pwedeng kalabasan ng uh, refraction. So, red, orange, yellow, green, blue, violet. Okay, so red 400 nanometer and violet 700 nanometer. Okay, tama ba siya or hindi siya consistent doon sa binanggit natin kanina? So, yun. I think mali yung una nating diniscuss. So, baliktad yata siya doon sa discussion kanina. So, red ay meron siyang 400 nanometer in yung kanyang wavelength, yung length ng wavelength, ah, redundant. Okay. And violet has a 700 nanometer wavelength. Okay. So I think this is correct because anong kasunod ng violet? Okay. Ang kasunod ng violet ay ultraviolet rays. And also you can see, okay, yung haba ng wavelength nila. Okay. Then microwave, very short wavelength. Okay. Higher than broadcast RF but lower than infrared yung kanya energy and wavelength. So anong effect ng microwave? Siyempre heat, di ba? Na paano natin nasabi o paano natin napatunayan? Okay? Siyempre, gumamit ka ng microwave oven. So ano mangyayari sa nilagay mong pagkain? Diba, iinit siya. Particularly, mas mainit yung kanyang loob. Mas mainit yung loob ng particular food compared dun sa labas. So usually kasi natatrap yung init, yung heat doon sa loob. Kasi shorter wavelength. Sorry, baliktad. Longer wavelength. Okay? So ionizing radiation, higher energy, okay, shorter wavelength, characterized by the energy contained in a photon. So an X-ray photon contains considerably more energy than a visible light or an radio frequency photon. Okay, bakit? Kasi nga, yun, by virtue of the wavelength. So again, what is the difference between X-rays and gamma rays? Very good, its origin. So X-rays, it is emitted from the electron cloud or the electron uh, orbital electrons, and gamma rays, it is emitted from the nucleus. Okay? The X-rays produced in diagnostic imaging systems, gamma rays are emitted spontaneously from radioactive material, or it is a process of radioactive decay. Okay. So yan yung ating illustration ng difference or ng production ng X-ray and gamma rays. However, pagdating natin sa characteristic and Bremsstrahlung X radiation, so baka uh, magkaroon kayo ng question. Okay? It is sometimes said that gamma rays have higher energy than X-rays. So in fact, in the earlier days, it is considered as so. Sinasabi ng iba, mas malakas ang gamma rays compared sa X-rays. However, it is proven, okay, that X-rays can also be or can also have uh, higher energy than gamma rays. Kaya nga basically Kapag kino-compare si X-ray and gamma rays, actually ang binabanggit lang lagi is the difference of their origin. Okay? So ayan, binanggit ulit. The only difference between X-rays and gamma rays is their origin. Their speed is the same. Okay? Their energy can be the same. Then visible light is identified by wavelength. Okay, bakit? Kasi depende sa wavelength yung color ng visible light. Then radio frequency is identified by, of course, frequency. And kaya nga 'di ba yung mga radio stations, 'di ba ano yung mga binabanggit nila, mga kilohertz. Then X-rays are identified by energy. Okay? So tandaan natin yan visible light, wavelength. RF, frequency. X-rays, energy. Okay? So this is the electromagnetic relationship triangle. So we have the wavelength, the frequency, and energy. Okay. So may formula siya. Ba nandyan? Okay. So yung formula niya is C equals F times lambda. So yung F frequency, okay, yung lambda is the wavelength, and yung C ay, ano yung C? Velocity. Okay? Yan. And meron ditong binabanggit na Planck's constant. Okay? So we will be discussing this formula, okay, in the laboratory in the second rotation. So simple lang naman yung gusto ko ipakita ng electromagnetic triangle or relationship triangle na ito. Na yun pa rin, the frequency and energy is directly proportional, while frequency and wavelength is inversely proportional, and wavelength and frequency is also inversely proportional. Ah, wavelength and energy. Okay? So ano yung inversely proportional? Dalawa. Wavelength and frequency, saka wavelength and energy. Okay? The relationship is both inversely proportional. And frequency and energy, ang relationship niya ay directly proportional. Okay, malinaw po? Okay. Meron pa bang hindi nakakaintindi ng kapag sinabi nating directly proportional? Or when we say inversely proportional? Meron po bang nalilito? So, assuming na merong nalilito, kapag sinabi nating inversely, so let's have the example of wavelength and frequency. So they are inversely proportional. The shorter the wavelength, uh, the greater the frequency. Okay? So, inversely yon. Kasi habang lumiliit yung wavelength, dumadami yung frequency. Diba? Lumiliit, dumadami. Kapag naman directly proportional, let's take energy and frequency. The greater the frequency, the greater the energy. Habang dumadami yung frequency, lumalakas yung energy. Ganon din. Habang lumalakas yung energy, dumadami yung frequency. Okay? Clear na tayo dyan ha. So we now move to the particulate radiation. So first of the particulate radiation is the alpha radiation. So it is symbolized by the small letter or small Greek letter alpha. Small po yan ha, kasi ang uh, large tuloy, big letter na Greek ay yung katulad ng Latin letter na letter A. Okay? So Greek tuloy. Alpha radiation do not penetrate matter easily as other types of radiation. Okay? So again, it has a mass of 4 and a charge of positive 2. Okay, best described as a doubly ionized helium nuclei. It is produced by radioactive decay, so primarily of heavy radioisotope. So, ito ang importante ngayon, bukod sa kanyang mass at charge. Okay. Yung kanyang range of energy. Alpha particles have a range in air of about 1 centimeter per mega electron of energy. Mega electron volts. Diba? Ganun siya kabigat. Imagine, it is already mega. Mega na siya. Okay? So 1,000 electron volts. 1 centimeter lang ang kanyang kayang i-travel in air. Kada 1,000 electron volts. Okay? Kaya naman siya ay na si shield or hindi siya tumatago sa paper or sa layer natin skin natin. Kaya siya ay delikado sa ating skin. Kasi alpha emitters can accumulate in the skin. Okay? It can cause local damage. Kasi nga, hindi siya nagpapass through. Natatrap lang siya dun sa skin. Again, its range and energy is 1 centimeter per mega electron volts of energy. Okay? Beta radiation. Okay. So, same. These are produced via radioactivity or radioactive decay. It is symbolized by the small Greek letter beta. Okay? It can travel approximately, yung kanyang range ay 12 feet per mega electron volt of energy in air and several millimeter in tissues. Okay? So again, it is still it can travel only in a few feet, 12 feet lang. Okay? Pero compared mo naman doon sa alpha particle or alpha radiation that can only travel for how many? 12 centimeter. 12 centimeter. So, ilan nga? 12 centimeter ba? 1 centimeter. Ayun. Okay? So, beta particle can be shielded by wood. Okay. It can penetrate the body 0.2 to 1.3 centimeter depending on the energy. It can also cause skin burn, okay, same as the alpha, or be an internal hazard if it is ingested. So sir, paano naman may ingest ang beta radiation? Oh. Kung nakapag-ingest ka ng radioactive material na beta emitter or nagdi-decay ay beta ang kanyang product. So, yan. It is an internal hazard. Okay? Bakit? Kasi mabigat pa rin siya. 12 feet lang in air. Tapos, 0.2 to 1.3 centimeter lang ang natatravel niya sa body or sa tissue. Diba? So, this is the graphic representation of the types of radiation and penetration. So, alpha particle, magharang ka lang ng paper, safe ka na. Okay? Beta particle, tumago ka lang sa isang aluminum wood, sa aluminum or sa wood, safe ka na. Hindi ka na tatamaan ng beta radiation. So however, X-ray and gamma ray, tatago sa paper, tatago sa aluminum and wood, pero siya ay ma-block ng lead. Okay? And of course, X-ray and gamma ray, hindi naman siya particulate radiation. However, neutron is a particulate radiation. So, neutron can pass through paper, aluminum, and even lead. So, anong protection mo? Concrete. When we say concrete, semento, buhos. Gano'ng kakapal? 6 inches. Okay. Kaya kung mapapansin niyo yung mga sinaunang X-ray laboratory, okay, ang mga harang nila or kanilang mga primary barrier ay concrete. Hindi lang basta concrete, kung hindi makapal na concrete. Pero yung mga modern na ngayon, ang kanilang shielding lang ay lead. Okay? So may question po doon sa types of radiation. Okay, bago tayo pumunta sa wave particle duality. Do you have any questions? Clarifications? Violent reactions? Okay, so wala. Ganyan naman, magmo-monologue tayo. Okay, so wave particle duality. So we have the visible light photons, okay, and they behave more like waves. Diba? Kasi nga wavelength. Then, X-ray photons, okay, they travel more or they behave more like particles. Tama ba? Hindi ba waves? Particles or waves? Ang X-ray. Okay. So, ganito po yung concept ng wave-particle duality. Okay. According to this theory, okay, that the electromagnetic spectrum, lahat ng nandun, okay, they can either be presented as a wave or a particle, meaning visible light can also be a particle and also be a wave at the same time. Radio waves are the same. It can also be waves, it can also be particle. Okay. However, yung concept ng wave and particle dito, uh, it uh, it must not be taken in the uh, classical physics. Yung classical definition ng waves and particles ay hindi nag-a-apply sa wave and particle duality. Okay. So dito papasok yung quantum mechanics. Diba? Quantum mechanics. Kasi uh, visible lights, though they are waves, however, we can quantize visible light. Bakit? Kasi visible light have photons. Okay, and photons is a quantum of energy. Diba? Quantum of energy. And quantum of energy are particles. Tama ba? Tama po ba? Baka mamaya mali ako. Nakikinig kayo. So, tama ba? May violent reaction ba kayo? Or may tanong ba kayo? Same with X-ray. Diba? X-ray ay, kung makikita natin kadalasan, representation niya, siya ay nire-represent as waves. As waves, ha? However, X-ray, photons. May tinatawag tayo X-ray photons. And like visible light, photons are quantum of energy, a bundle of energy, or bundles of energy. And these quantum of energy are composed of energy particles. Okay? So, nalilito? Of course. Nakakalito. But that is what wave-particle duality is. Sabi nga, it is weird daw. Okay? Weird siya. So, basically, when we say, yan, wave-particle duality, so a photon of radiation, X-radiation, and a photon of visible light are fundamentally the same. Parehas lang. Diba? Except for, of course, the frequency and wavelength, and of course, the energy. So, do you mean that X-rays and visible light are both waves and particles? Or they are composed of waves and particles? Okay. So, according to quantum mechanics, kailangan daw hindi natin ibabox yung wave sa classical definition niya as parang wave sa dagat. At the same time, particle, hindi rin dapat natin siya i-box sa definition ng particle as yung small na bilog. Okay? So, napaka-weird na theory, di ba? But it is there. Kaya lang, siyempre, in the purpose of our general discussion, we will stick to uh, our description of kapag electromagnetic waves, so they are in waves. Kapag particulate radiation, so they are in particles. So anong result nito? Differences in the way these photons interact with matter. So yun lang naman yung result. Magkakaroon ng pagkakaiba. Siyempre, may pagkakaiba. Bukod sa frequency energy, yung wavelength, of course, yung penetration. Can visible light penetrate a particular object? Of course not. Only X-ray can penetrate an object, particularly a paper, a wood, or even human body. But the visible light cannot penetrate even a paper. Diba? Kaya nga yung flashlight, harangan mo ng papel, cut off na yung light. Because its energy cannot penetrate the paper. Unless na gumamit ka ng high lumen flashlight. Pero hindi pa rin. Cut off pa rin siya. Okay? So, wave-particle duality is the principle that states both wave and particle concepts must be retained, however, or because wave-like properties are exhibited in some experiments and particle-like properties are exhibited in another. Ibig sabihin, kapag nag-conduct ng experiment using, let's say, visible light, it demonstrated also not only wave-like properties but also particle-like properties. The same goes with experiments conducted with, let's say, positron or neutron radiation. Okay, it also can exhibit both wave-like properties and particle-like properties. Hence, wave-particle duality. Okay? Kasi ano ba ibig sabihin pag sinabihan ka ng let's say ng isang tao ng nagsalita siya or nag-react siya sa iyo or sa statement mo, ang reaction niya is parang the duality of this person. So ano ibig sabihin nun? Ibig sabihin you are portraying two properties or two sides. Diba? Duality. Okay. So photons interact with matter most easily when matter is approximately the same size as the photon wavelength. Okay? Mas madaling mag-interact daw yung photon kapag siya ay mag-interact sa isang object na parehas ng wavelength niya. Okay? So, example, radio waves and TV waves. So, they are measured in meters. They interact with the antennas. Okay? So, same daw yung wavelength nila. Microwave, measured in centimeters, interacts with hot dogs and hamburgers. Okay, mahilig dyan sa hot dogs and hamburgers. Okay? So, kasing haba lang sila ng wavelength ng microwave. Then, visible light, measured in nanometer. So, it interacts with the rods and cones of the eye. Okay, saan ba matatagpuan ng rods and cones? Diba? Sa gitna ng ating mga mata. Then UV light interacts with molecules. X-rays interacts with the electrons. Okay. So wave phenomenon. So sabi dito, all radiation with wavelength longer than X-rays. Wave phenomenon. Okay? So meaning, lahat ng radiation na longer ang uh, wavelength, okay, they cannot penetrate the body. Okay? So wave model, visible light. Okay. So sensed by human eye, of course, nakikita natin kaya nga siya ay visible light. So tama yung kanina natin do sa photo. The violet has the shortest wavelength and red naman ay may longer wavelength compared sa violet. Okay? The difference in wavelength is proportional to the energy. Kaya siya ay anong relationship? Anong relationship? Energy and wavelength? Energy and wavelength? Inversely? Are you sure? Energy and wavelength. Inversely. Pakibasa nga. Basahin. Nako. Ayan. Nalibog na. Nalito na kayo. Hoy, Bisaya man yun, ha? Dili man yung Tagalog. Kay Bisaya man yun nalibog. Oh, ano? Anong relationship? People. Yung directly proportional. Oh, how about the others? Yung mga hindi sumasagot. Yung mga invisible. So what is the relationship? Kaya sabi ng classmate nyo kanina, inversely proportional. Then ngayon naman, directly proportional. So, ano? Ano ang inyong kasagutan? Okay. So basahin ko basahin ko.
Kasi po si energy at frequency po ay directly proportional. Yung frequency po ay inversely proportional sa wavelength.
Ang tinatanong ko is, wavelength and energy.
Inversely nga po.
Inversely ang wavelength and energy. Ayan nakalagay na the difference in wavelength is proportional to the energy. Di ba? Bakit? Then, proportional ba? The difference in wavelength is proportional to the energy. So anong relationship? Ano? Pinangangatawanan mo ba, Earl, ang sagot mo? Directly, inversely, directly. Nako. So, sino yung sumasagot kanina na kino-compare niya yung tanong ko sa frequency and wavelength? Si Graciela. Okay. So, pangangatawanan mo ba yung sagot mo? Graciela, paninindigan mo. Ba kailangan manindigan? Kaya dapat rehistrado kayo para makaboto. So, ikaw Earl, paninindigan mo. O kasi yung iba niyong classmate walang paninindigan. Dalawa lang naman yung pamimilian, di ba? Inversely. Yan. Tama naman, inversely. Kayo naman, sinisindak lang kayo eh. Nagbabago na agad kayo ng sagot. Okay. So paano siya naging inversely samantalang ang nakikita nyo dito nakasulat is proportional. Remember the word before wavelength, the difference. The difference in wavelength is proportional to the energy. Okay, yung pagkakaiba ng wavelength. Okay, so that still means, ang ibig sabihin pa rin itong statement na to, okay, the shorter the wavelength, the greater the energy. And the greater the energy, or the longer the wavelength, the lesser the energy. Okay? So visible light behaves like waves and X-rays behaves as though they were particles. But all the same, they can both behave as either wave or particles. Okay? So, visible light spectrum extends from short wavelength, okay, short wavelength violet radiation to green and yellow to long wavelength red radiation. So, yung ating visible light, meron siyang sariling spectrum. Okay? And again, visible light is measured in nanometer. Ang unit niya ay N at small letter N at small letter M. Okay? So kapag lumampas na siya doon sa pinaka mataas na or pinaka maikling wavelength at pinaka mahabang wavelength doon sa visible light spectrum, hindi na siya makikita ng ating mga mata. Okay? Another thing, uh, visible light is related also with temperature. The higher the temperature, okay, the temperature of a particular object, okay, the greater the possibility of it to emit light. So ano bang temperature? Ano bang temperature kailangan para makapag-emit ng light ang isang object? So according to science, you need at least 3010 Kelvin. So, ibig sabihin, ganon kainit, 3010 Kelvin. Kung ikaw ay tao, lusaw ka na niyan. Diba? Para daw mag-emit ng light. Kaya example natin dito, kapag nagpapanday ng metal, diba? Yung blacksmith or yung panday, anong ginagawa niya sa metal para ma-reshape niya? Diba? Iniinit niya. Uh, kumbaga, sinasama niya sa mga coal. And then, ano pa siya ng air para lalong tumaas yung temperature. So, nilagay niya, halimbawa yung metal doon. So, ano itsura ng metal? Let's say, uh, lead yun. Oh, hindi lead. let's say, uh, color black yung metal, diba? Pag kuha mo doon sa metal, paghugot mo doon sa uh, na-heat na siya, ano ng kulay? Diba amber? Either amber or yellow. So nag-i-emit na siya ng light. That means na-reach niya yung certain temperature, which is at least 3,000 Kelvin. Okay? So ganun din yung ating mga light bulbs. Okay? So sa ngayon, 'di ba, konti na lang yung gumagamit ng uh, yung yellow na light bulb. Though makakakita kayo ng mga retro na light bulbs, nakita yung filament, 'di ba? Kita yung filament sa loob. Okay? So ibig sabihin nun, sobrang init kaya siya nagpro-produce ng light. Yung filament niya ay nagpro-produce ng light due to increased temperature. So ganun din dito sa ating visible light. So electromagnetic energy attenuation, the reduction in intensity that results from scattering and radiation. Okay. Visible light can similarly interact with matter. So reflection from a silver surface mirror is common. Okay. So nakalagay dito, transmission, absorption, attenuation. So ano bang pagkakaiba ng tatlo? Okay. When we say transmission, parehas ba siya ng absorption? Hindi, di ba? So, ayan. Sige. Example natin dito. Interaction between light and absorbing material. So, transparency, transmission. Hindi siya na-absorb. Siya ay nag-pass through lang. Dumaan lang siya, yung light. Example, yung ating glass window na clear glass window. So, pag nag-flashlight ka dyan, tatagos lang yung ilaw. Tama? Then, translucency, partial absorption, or attenuation. Okay? Again, you must remember this term, ha? Attenuation, ang ibig sabihin niya, partial absorption. Okay? Translucency example na dito is frosted glass. Okay, pag nag-flashlight ka sa frosted glass, hindi naman yung or yung intensity ng light nababawasan. May tumatagos na ilaw pero hindi ganoon kataas ang or hindi ganoon kaliwanag. 'Di ba? Tama ba? Bakit hindi ganoon kaliwanag? Because okay, some of the light photons are being absorbed by the frosted glass. Then opacity, completely or complete absorption. So black glass. Kapag nag-flashlight ka sa black glass, ano nangyayari? May tumatagos ba na light? Wala. Why? Because black absorbs the light emitted by your flashlight. Yan. So, example yan ganito. Okay? So, we have the transparent, translucent material, and opaque material. Okay? Transparent yung window, clear, so the energy or light energy can pass through. Lahat sila. Sa frosted glass, hindi lahat nagpapass through. Kaya yung intensity ng light or yung energy ng light pag doon sa kabilang side ay humihina. And doon sa opaque material, which is a black glass, all the light photons are being absorbed by the material. Okay? Nakuha po ba? Na-gets po ba? Okay, in radiography, meron tayong term na ginagamit. Meron tayong radiopaque, radiolucent. Kapag radiopaque, ibig sabihin ito ay whitish in color. Radiolucent ay black in color dun sa film. Okay? So share langs yun. Share langs. Hindi pala. Ito pala yun. Radiopaque. So the structures that absorb X-rays, like bones, are illustrated as radiopaque in the radiograph. And the structures that transmit light or that transmit X-rays, example ay lung tissue, they are presented as radiolucent. Okay. So, paano naman na-absorb ng bone ng X-ray? Okay. Okay. The penetrability of X-ray depends upon the density of uh, the density of the anatomical structure. Okay. When we say density, yung composition ng particular anatomic structure. Let's say kapal, yung bone. The bone is the most dense. Siya yung pinaka-dense na anatomic structure sa katawan ng tao. Maliban na lang kung ang isang tao ay may osteoporosis. Kasi nawawala yung, nababawasan yung density. Okay? So, the more dense the anatomic structure, the more it absorbs X-rays. Okay. The more or the lesser the density of an anatomic structure, okay, the lesser the amount of X-ray it absorbs. Meaning, magpapass through lang yun. Okay? Kaya pag tinanong kayo ng pasyente, okay lang po ba magpa-X-ray? Magpa-chest X-ray ngayon? Kakapa-chest X-ray ko lang po 6 months ago. Wala pa pong 1 year. Okay lang po ba? Anong sasagot nyo? Okay lang po. Kung gusto niyo po 100 pa eh. Hindi, joke lang. Siyempre, sasabihin niyo okay lang. Pag tinanong kung bakit, ang sasagot niyo, minimal radiation dose lang naman po yung ginagamit natin for chest x-ray. And you need almost 300 chest x-ray to reach the annual limit. Okay? So yun. So again, yung radiopaque, ang itsura niya sa x-ray, anong kulay? White. Very good. Radiolucent, so ang itsura niya sa x-ray ay black. Okay? Or not totally black, mga blackish in color. Ganun. Okay? So yan. Radiopaque and radiolucent. Kapag soft tissue, radiolucent. Okay? Uh, yung radiolucent ay it can either be grayish in color papunta sa black. Okay? Depende sa contrast, radiographic contrast. Okay? But definitely, bone ay white. Okay, so inverse square law. Again, yung formula or yung computation, reserve natin yan sa laboratory. So inverse square law states that the intensity of radiation, okay, is inversely proportional to the square distance of the radiation from its source. Okay. So, anong ibig sabihin? So, ang ibig sabihin lang, para rin lang yung wavelength at energy. Okay? Mas malayo ka, ay ano, mas malayo ka sa source ng radiation, mas okay, tama, tama. Inversely proportional nga, di ba? So meaning the the closer you are to the source of radiation, the higher the intensity. Ibig sabihin, yung distance mo, mas malapit ka sa source ng radiation. Yung intensity ng radiation, mas mataas. Malapit sa source, small, mataas yung intensity, big. So, inversely proportional. Okay? Malayo ka sa source ng radiation, so yung intensity ay maliit or mahina. Okay? Example, pwede nyo gawin sa bahay. Kumuha kayo ng flashlight. Mas maganda yung flashlight talaga kaysa sa flashlight ng cellphone. Kasi yung flashlight talaga, di ba, meron siyang, meron siyang shape, circle. Ba? Tapos, ang gawin nyo, open nyo yung flashlight, tapos ilapit nyo siya uh, sa isang wall or sa inyong table or sa surface ng inyong laptop. Ganun, taas baba. So makikita nyo, kapag or ilayo nyo, ilapit nyo yung flashlight. Kapag inilapit yung flashlight, mas maliwanag yung ilaw na na makikita nyo doon sa wall. Kapag inilayo nyo yung flashlight, ano nangyayari? Lumalabo yung ilaw, pero lumalaki. Diba? Lumalaki yung kanyang uh, range, pero o yung kanyang region of exposure, pero yung intensity niya nababawasan. So, ganun lang yung gustong sabihin ng inverse square law. Okay? Yes. Okay. So, the difference is, of course, the energy. Yung energy. Okay? Uh, sabi ko nga sa inyo, ang light, di ba, ang light naman ay may different type of energy rin. Depende do sa lumen na tinatawag. Diba? Compared mo ang isang flashlight na may 10 lumens, compared mo siya sa flashlight na may 100 lumens. So definitely, mas maliwanag yung merong 100 lumen. Kaya nga di ba pag bumibili kayo ng or kapag bibili tayo ng flashlight sa Lazada, isa sa mga description niya ay yung lumen. Ganon din kapag bibili tayo ng projector. Yung projector, diba merong lumens. So yung lumens ay actually, it is the intensity of light. Kaya sa mga problems natin regarding inverse square law, kapag light ang pinag-uusapan, we use lumens as the unit. Okay? Ayan. So, ang formula nyo dito is initial intensity over, sorry, it's not initial. Intensity 1 over intensity 2 equals distance 2 over distance 1 squared. So, yan yung formula. So, again, iwan muna natin si formula. Pero dapat maunawaan nyo yung inverse square law. Okay? Again, it states the intensity of radiation or light is inversely proportional to the square distance between the light and the source. Okay. So, yung light, yung nagpro-project dun sa wall. Then, of course, yung source, yung iyong flashlight. Okay? So, usually ito ay pinamemorize ko. So, alam nyo na, yung inverse square law. Kasi very important yan sa practice natin. So, sa ano pang paraan may apply ang inverse square law? Sa radiation protection, may apply ang inverse square law. Okay. So, kapag nag-fluoroscopy tayo, or kapag may nag-fluoroscopy na procedure, usually, kung ikaw ay manonood lang naman, hindi ka lalapit doon sa source. Dapat mas malayo ka. Or let's say, isa kang nurse at tutulong ka sa isang procedure, interventional radiology. Okay? As a nurse, dapat may alam ka sa radiation protection. Lalo na kung ikaw ay radiology nurse. Okay. So dapat alam mo yung three cardinal principles in radiation protection, which is time, shielding, and distance. Or time, distance, shielding. Time, dapat shortest time possible yung exposure. Distance, kailangan increase distance from the source of radiation. So kung ikaw ay nurse, mag-assist ka at naiabot mo na ang gamit sa doktor, so you must distance or you must increase your distance from the patient and from the source. Usually, the source of radiation is just on top or at the uh, under the patient kapag ito ay fluoroscopy. Okay? So you have to increase distance. Siyempre, provided na doon uh, na may tawag dito, na may shielding. Provided na may shielding yon. Ano yung shielding? Rubber leaded apron, rubber leaded thyroid shield, and leaded goggles. So lahat yan ay ginagamit kapag nagkakandak ng uh, fluoroscopic exam. Okay? Okay. So the reason for the rapid decrease in intensity with increasing distance is that the light emitted is spread out over an increasingly large area. So di ba yun nga yung pinaliwanag ko kanina, habang lumalayo ka or pag nilayo mo yung flashlight, anong nangyayari? Lumalaki yung area, nag-spread out habang humihina yung intensity ng light. So yun yung reason sa paghina ng intensity. Okay? The equivalent of this phenomenon in water wave analogy is the reduction of wave amplitude with the distance from the source. So ganun din daw. So tama naman, di ba? Habang lumalayo yung wave doon sa source, doon sa pinanggagalingan ng wave, di ba? Humihina siya compared sa uh, malapit na wave doon sa mismong source. Okay? So electromagnetic energy or electromagnetic radiation, uh, yung intensity niya ay inversely proportional to the source or to the square of the distance from the source. So again, it is the inverse square law. Okay, the inverse square law can be applied to the distance greater than 7 times the longest dimension of the source. So it can be 7 times na. 7 times na yung uh, pagkakaiba nila or yung longest dimension. Pwede pa rin i-apply si inverse square law. Okay. So to apply the inverse square law, you must know that 3 of the 4 parameters consist of 2 distances and 2 intensities. Okay? So, ano na to, papunta na to sa computation eh. See? So ito yung example. So pwede naman daanan lang natin muna. Pero yung mismong activity nyo ay next time or sa second rotation. So the intensity of light from a reading lamp is 10 millilumens. I2 at a distance of 1 milli or 1 meter pala at the distance of 1 meter. So D2. So the given is I2 and D2. So the lumen is a unit of light intensity. What is the intensity or I1, intensity 1 or of this light at 3 meter? So distance 1. So given yung distance 2 and intensity 2 and distance 1. Okay. So using the formula, I1 over I2 equals D2 over D1 squared. Okay. So substitution ng mga given. So I1 over 100 millilumens equals 1 meter kasi yun yung D2. The D1 is 3 meters squared. Okay. So ililipat natin si I2 sa kabila. So from being denominator, magiging siyang uh, ano tawag doon? Denominator, numerator. Okay? So mapupunta siya sa taas. So magiging the formula will be 1 I1 equals I2 times D2 divided by D2 squared, D1 squared. So ganyan yung magiging itsura niya. Okay, so 100 millilumens times 1 over 3 meters squared. So remove cancel the unit meters. So 1 over 3 squared ay 1 over 9. So 100 milliliters, millilumens times 1 divided by 9. Okay? So the answer would be 11 millilumens. So ano napansin nyo? Ano na, tama ba yung result? Napatunayan ba niya yung inverse square law, yung concept ng inverse square law? So now the missing the intensity one is 11 millilumens. So meaning, the given 100 millilumens at the distance of 1 meter, okay, kapag ginawa mong 3 meters yung distance, okay, from 100 millilumen, magiging 11 lumen na lang yung kanyang intensity. So, does it reflect the inverse square law? Yes. So, ayun, very good. Intindihan po ba? Okay. So, ayan na. Pag hindi naintindihan, magsabi po. Okay, so this relationship between electromagnetic energy, intensity, and distance, okay, from the source applies equally well to the X-ray intensity. Bakit? Kasi, yun, part naman ng electromagnetic radiation spectrum ang X-ray. Okay? So, ayan. Exposure from an X-ray tube operated at 70 kbp, 200 MAS is 4 milligray at 90 centimeter. So what will be the exposure at 180 centimeter? So anong given? Okay? So meron tayong dalawang distance at isang intensity or penetrability. Okay? Or exposure pala. Hindi penetrability, exposure. Okay? So, ganoon pa rin. Okay? Kailangan nating i-analyze yung question para makuha natin kung ano yung given. Okay? Katulad dyan, may KBP, may MAS. Pero ang tanong, what will the exposure be? Okay, exposure. And exposure has a unit of gray. Okay, that's why uh, doon sa hiningi kong klase sa inyo sa Friday, i-discuss natin yung mga radiological radiation quantities and units. Okay, para familiar kayo kung ano yung mga proper term or proper units na ginagamit sa radiation. Let's say, dose ng patient, radiation dose ng patient, or radiation dose ng uh, radiation worker, or exposure, ano yung unit na exposure sa air. So dapat familiar kayo doon, and we will be uh, discussing it sa Friday. Okay? So you can also read that in your book. It is, I think, in chapter 1. Basta yung may mga scientific notation. Okay? Okay. So, ayan. Following this problem daw, so this example illustrates that when the distance from the source is doubled, the intensity of radiation is reduced to 1/4. Okay. Conversely, when the distance is half, kinalahati, okay, the intensity of radiation is increased by a factor of 4. So, tama naman. Diba? From 4 milligray, naging 1 milligray na lang siya. Okay? Bakit sinabi na kinalahati yung distance? Kasi from 90, okay, from 90, okay, dinagdagan uli ng 90, so kalahati yung distance niya. Okay? Nadagdagan ng kalahati. Ay, ba't pabalik? Okay. So, lampasan na natin yan. Meron pa ba? Okay. Source of electromagnetic energy. So, line source. Okay. Line source. Ibig sabihin ng line, uh, inversely or yung inverse square law does not hold at distances closest to the source. So ano ibig sabihin? Ng inverse na the inverse square law does not apply at the distances closest to the source. So ano ibig sabihin niya? Line source. Hindi daw magagamit yung inverse square law sa mga distances na sobrang lapit sa source. Okay? Tama ba yun? Okay. Sasagutin natin yan sa inyong laboratory. Kasi doon tayo magko-compute. So titingnan natin sa computation kung pag nag-compute tayo na sobrang lapit doon sa source, titingnan natin kung parehas pa rin yung makukuha nating relationship or not. Okay? So, laktawan natin yan. Okay. The particle model or quantum theory. So, babalik tayo dun sa particle wave duality. Okay? Kasi it is part of the quantum theory. Okay? So X-rays are identified by their energy, which is electron volts. So usually, the energy range, okay, for X-rays are 10 kilo electron volts to 50 mega electron volts. And the wavelength is 10 to the negative 10 to 10 to the negative 14 meters. Frequency is 10 to the 18 to 10 to the 22nd hertz. So all electromagnetic radiation can be visualized as two perpendicular sine waves. Okay? Electric and magnetic fields that travels in a straight line at the speed of light. So they can be visualized, ha? Visualized. Pero yun, not necessarily ay ganun nga siya kasi nga uh, because of the uh, wave particle duality. Okay. So the X-ray photon is a discrete bundle of energy. Okay? So ang isang photon malakas na energy na yung kanyang uh, dala-dala. Okay? Okay, so Planck's quantum theory. So X-rays are created with the speed of light. Okay? X-rays exist with the velocity or they do not exist at all. Well, tama naman. So, ang ibig kasi sabihin dito, paano ba na-produce yung X-ray? Okay. So, they are created in the speed of light. Sa paanong paraan? Ano ba yung nag-produce ng X-ray? Okay. So, sa ngayon, i-hold lang muna natin yung sagot kasi we will be discussing that on the next module, which is X-ray production. Okay? So, paano na produce yung X-ray? At bakit sinabi dito na X-rays are created with the speed of light? Okay? Hold lang muna natin yan. So, you can take down or take note of that para just in case na makalimutan natin sagutin, so you can remind me. Okay. So, it is Max Planck that synthesizes our understanding of electromagnetic radiation. Okay? Kasi uh, doon sa electromagnetic spectrum, yung mga longer, yung mga long wavelengths na belonging to the uh, let's say, belonging to the non-ionizing radiation. So madali silang na-explain through classical physics. However, pagdating na doon sa mga shorter wavelength, nahirapan na yung mga physicists i-explain. So, ayun, dumating si Max Planck. At uh, doon na nga niya pinag-aralan at synthesize yung uh, understanding or yung concept and theories about electromagnetic radiation by means of the quantum theory. Okay? Kinanta, quantization, something like that, quantization of the photons. Okay, isa yun sa part ng theory ni Planck. And may tinatawag na Planck's constant. So that is included in the formula doon sa uh, electromagnetic uh, relationship triangle. Okay? So the Planck's constant, ang symbol niya is letter H. Okay? And the value of that is 4.5, 4.15 times 10 to the negative 15 electron volts seconds. Okay, hindi yan per second electron volt seconds. Or 6.63 times 10 raised to the negative 34 joule seconds. Okay? So the quantum equation, so mapapansin nyo, halos parehas noong nandun sa uh, formula ng uh, wavelength and wavelength, frequency, and velocity. So meron lang mga additional like yung letter E which is the energy. Okay? So equivalent equations, frequency equals energy over Planck's constant. And then energy kapag given yung wavelength. So Planck's constant times velocity, okay, or speed of light. No, so divided by the wavelength. So yung mga ganyan. So yan ay sa uh, laboratory natin iti-take up. Okay? So these are types of X-rays or the ranges ng X-rays and its application to in medicine research and industry. So diffraction, so siya ay less than 10 kbp. Application niya is research and molecular analysis. Grains X-ray, 10 to 20 kbp. Application niya is sa dermatology. Okay? Superficial X-rays, 50 to 100 kbp, so medicine. Diagnostic, so tayo, ang ating ginagamit lang dito ay diagnostic and ortho voltage. Okay? Diagnostic, ang range niya is 30 to 150 kbp. Ortho voltage is 200 to 300 kbp. Then super voltage, 300 to 1000 kbp. And mega voltage, which is more than 1 megavolts. Okay. So ginagamit siya sa medicine and industry or industrial uh, use of radiation. Okay. So the energy of a photon is directly proportional to its frequency. Inulit na naman natin. Okay, so ito yung explanation ng quantum equation. E is the photon energy, H is the Planck's constant, F is the photon frequency in hertz. Okay. So, ito yung sinasabi kanina na you can visualize electromagnetic energy as a two sine waves of magnetic and electric field. Okay? So yan yung lang naman. Representation lang naman yan. So as you can see, halos pareha sila. Okay? And syempre they travel at the speed of light. Okay. So ito ay importante rin natin o dapat alam din natin to. So alam niyo ba to? The law of conservation of matter and energy. So the law of conservation of matter states that matter can neither be created nor destroyed, but it can transform from one form to another or one phase to another. But we have the phases of matter, the solid, liquid, gas, or states of matter pala, sorry. Then, the law of conservation of energy naman, so ganun din. It states that energy may be transformed from one form to another but cannot be created nor destroyed. And the total amount of energy remains the same or constant. So kahit siya ay mag-transform from one form to another, the energy remains the same. Okay po, relativity, E equals mc squared. Okay, energy, letter E, then m is the mass measured in kilograms, and c is of course the speed of light in meter per second. Okay, so that ends my lecture for today. Of course, my reference is our textbook, Bushong, Stewart Bushong, Radiologic Sciences for Technologies. Okay, so thank you for uh, listening. So